All right, mathematicians. So this lesson's all about the absolute value function. Okay, it's the one that looks like a V. Um, so here we go. Now, like I said, completely optional. I do enjoy reading them. Seems like a lot of you are starting to go to the beach, taking some walks. One of you was pretty excited about the being able to ride your dirt bike again. So I guess somebody hit 10 subs on their YouTube, whatever that means. Congratulations. But it's always nice to read what you guys are up to, how you're feeling, the ups and the downs. Okay, totally optional. All right, here we go. So you're going to need this. So either you can kind of create your own copy in your notebook, or if you'd like, click on that link and it'll take you to the document and you can print it out. Okay, so you might want to pause this video to kind of set up your notebook in that way. Okay, so I'm hoping that you have this document or some sort of version of it in your notebook. Okay, so let's move on. All right, let's explore absolute value. Okay, so these little symbols, like the little vertical lines there, the absolute value of 5 is 5. The absolute value of 2,140 is 2,140. The absolute value of negative 52 is 52. The absolute value of negative 20 is 20. So how would you define absolute value? Okay, so I expect your own thoughts here. Nothing from Google where you copy and paste because it's pretty evident because when people start doing that, it's literally the same definition because it's the first link they find. So in your own words, what does absolute value mean? Okay. So hopefully you have a good idea, solid idea what the absolute value function is, that symbol. And we're going to complete this table together, okay? So if you notice, when I plug in the number -4 into my function, so what's the absolute value of -4? So really the absolute value is asking how far is -4 from 0, the distance from 0. That's like the most like mathematical definition of the absolute value. Some people might just say, oh, your answer is always positive. When you take the absolute value, it's always positive, which is true, but really they're talking about how far is your number, the distance from 0. How far is your number from 0? So how far is -4 from 0? Just 4. So the absolute value of -4 is 4. Now let's follow the same pattern. If I take the absolute value of a number, I get 1. So it could be either 1 or -1. But to maintain the pattern, we'll put -1 there because the absolute value of -1 is 1. So if you notice, it's starting to populate on our graph. It's starting to appear. If I did something wrong, you'll see a dot appear off the line. So the absolute value of something is 0, 0. The absolute value of 1 is 1, and the absolute value of 4 is 4. So the absolute value function is, like I said, is a V. Okay, you're going to get a V. It's a V shape. So what we're going to do, let's draw the map diagram, okay? So on the left side, I have -4, -1, 0, 1, and 4. And then on the right side, I just list the elements once. So if I have 4 twice, I just list it once. So just to make my life, well, I'll just put it in orders in terms of from least to greatest. So first it's 0, and then 1, and then 4. Okay, so what I just did was arranged it from least to greatest. And the reason why I'm not putting 2 ones, you only put it once, okay? So you already learned this in the previous lessons. So -4 goes to 4. Okay, good. -1 goes to 1. And I'm getting this from my table. 0 goes to 0. Okay. 1 goes to 1. Okay. Now it's getting a little messy here. And then 4 goes to 4. Now remember, for it to be a function, every input has its own output. And if you look at this, look at the arrows. I always tell you to focus on the arrows. If there are one or more arrows leaving the input, then it's not a function. That's kind of a quick way to look at it. But if you notice, I only have one arrow leaving the input, one arrow, one arrow, one arrow, one arrow. So by definition, this is a function. Moving on. So let's explain why this function, the absolute value of x, creates a V shape. Now, what I want to do right now is I want to reveal the graph y equals x. So y equals x is this graph right here, this line right here, if you look at that. So think about it. It's literally taking this line, think about it, the absolute value of a negative is a positive. So it literally is just taking all of these negative values and is just making them positive. So that's why this line, instead of being here, it just switches up and it's now in the positive region, hence the V shape. Hopefully that made sense. Okay, click next. Alrighty then, what do we got next here? So what we now need to figure out, sorry, I think I skipped a slide perhaps. Yeah, so does the equation represent a function? Obviously it does. We've stated that multiple times, but we can do the vertical line test. If you notice, the vertical line only crosses the graph once. Okay, if you notice that, and we proved it in the previous slide using the mapping diagram that this is indeed a function. Okay. All right, number 9. So we're gonna play around with the function, the absolute value of x. This function, the absolute value function. Okay, we're gonna see how we change the value, what happens to our graph. Okay, so if I have the absolute value of x, now notice it over here, and I multiply it by an a, and notice where the a is. A represents a number. So if a is on the outside of the absolute value, if I multiply that, what happens to my graph, my absolute value graph? So the red one is the original. Now notice when I change the values of a, what happens to my absolute value graph? Okay, so we're gonna formalize these definitions pretty quick here. So you see that? All right, what I want you to do, take a few seconds and list your observations. That's what I want you to do. There's really no right or wrong answer here. List your observations of when you change the value of a in your graph, what happens to your absolute value function, okay? You might have to press pause here to type that in. All right, next. What happens if I add a value to my absolute value function? So let's say, what if I add a value outside of it? What happens to my graph? So plus k represents a number. Right now it's 0. So let's see what happens if I change it to positive. Positive 1, 2. Look at what's happening here. What is happening to my absolute value? Now remember, the red one is the original. Now what if I go down? What's going to happen? Okay. So what I want you to do here is type in your observations for what happens when you change the value of k, when you're adding a number to your absolute value function. Okay, so make those observations. Hint, hint, translation. Okay, so you might want to press pause and then pick this back up, okay? Next one. Now notice this is a little different. Now what happens if, now notice here how the standard form, you're going to learn the standard form of an absolute value function, but how they write it a mathematician would write it as x minus h. So h represents a number. So what I want you to do is slide this left and right. See what happens when you change the value of h. So if h becomes positive, what happens to my graph? Now be careful, it's a minus a positive. So this one gets a little confusing. This is how it's standard form. This is how it's written, minus your h value. So h is becoming positive. Then your h becomes negative. Now notice how it's written, minus a negative. This is going to be a little confusing. We're going to talk about it more in detail later on. But how would you write minus a negative? Adding a positive. But let's focus on when you change the value of h. When it moves to the right, it's positive. So I'm already kind of giving you the answers here. But you can kind of see that, right? Okay, so what I want you to do, list your observations. When you change the value of h, what happens? What happens to your graph? So remember, the h is what's inside the absolute values, okay? Make sure you remember that, okay? All right, moving on. So here we are. Hopefully you have your graphic organizer, and we're going to fill this out. This might take a little bit of time. I'm going to try to go nice and slow. So the absolute value function, this is the standard, basically what's called standard form. This is how you normally would write it. And then we're trying to see what happens when you change these values. What happens to your, basically what's called the parent function, the original function, the absolute value of x. All right, let's start with k. Right here, when we were changing the value of k, what did k do? So that's what I'm going to do here. What did k do? Okay, we're gonna start really formulating the vocabulary here. So when the value of k is positive, the graph translates up k units. Okay, so when k is positive, the graph translates up k units. So let's look. Let's look at our blue graph. It's translating up by the number of units it's indicating. So if you notice here, hopefully my little pointer here, and hopefully you can see my cursor. So it started at 0 and it moved up 5 units. Now it's at 5. There it is. Or sorry, yeah, 5. Okay. So what happens when the k is negative? What happens to my graph? The graph translates down k units. Okay, so the value of k, now be careful, the value of k is the number on the outside. Let me just get this at 0 if I can. Okay. So the value of k, it's what you're adding or subtracting, and it just translates vertically your graph up or down. Okay. So what about the value of a? What if it's negative? Okay. What happens when it's negative? So let's check. Value of a, I'm changing it to a negative value. What happens? The graph is now facing down. So what we would say is the graph opens down. So the value of a, if it's negative, you basically have a v, and it changes from facing up down to facing down. Oh, I can't really do that because that was awkward. But yeah, it's just facing down. Okay. So when the value of a is positive, your v is facing up, facing upward. Okay, notice that positive 3.2, that you have a v facing up. So let's write that. the graph opens up. So if you need a little indicator, so I'll draw a V facing down, opening down, a V facing opening up. Okay, that's what I mean by that. So when the value of A increases, okay, so this is where we have to be very careful. Okay, for example, so here we go. So right now our graph is at 1, right? So A is 1. When A is 1 with the absolute value of x, your parent function, the original, A is 1. So when the value of A increases, so let's increase it to 2, to 3, to 4, to 5. What is happening to the V? What is happening to that? Well, the graph becomes narrower. Okay, so we have to be careful here because we have to take into account, and this might confuse some of you here. So when the absolute value is greater than 1, so I'm taking my A value, and if it's greater than 1, it's getting narrow. Now, my V is getting narrow, but we also have to take into account when it's facing down. So that's why I do the absolute value of A, because look, if I do -1, and then I increase that value, I'll get, or technically decrease, but if it goes from -1 to -2 to -3 to -4, so for example, -5, a value of -5 makes it really, really narrow. I know it's facing down, but it's super narrow. So that's why I put the absolute value of A, because what's the absolute value of A? Sorry, what's the absolute value of -5? 5. And 5 is greater than 1, which means you're going to get a narrow V. Now, in this situation, the V is facing downward. Okay? Now, next one. I know this is a little tricky, I know. Sorry, tried my best to explain that one there. Now, let's set our A back to 1, because that sets us back to our original statement, back to function of x, absolute value of x, sorry, the absolute value of x, okay? So what happens if we decrease A? Just slightly, a little bit. Notice what a blue graph did? Just slightly, a little bit. So we'll just stop right there. And what it did was the graph became wider. The graph becomes wider. Now, in this situation, this one's a little tough. We're really focused in between where your graph becomes wider is in between 0, the absolute value of A, and 1. Basically, a number between 0 and 1. If A is in between 0 and 1, you expect your V, your absolute value function, to be pretty wide. Okay? So anywhere in between 0 or 1, you expect that V to be pretty wide. But the reason why I put absolute value is because we have to take into account when it's facing down. Because in between 0 and -1, it's still pretty wide. Okay, so remember, as soon as we go beyond -1, that's when it starts becoming narrow. Remember, because the absolute value of -2 is 2, which is greater than 1, and it makes it narrow. So you see how that works? These two are a little tough, okay? Another way of just looking at it is if you have anything in between 0 or 1, or yeah, between 0 and 1, basically a fraction, you're going to have something pretty wide. And if it increases, it's greater than 1, it's going to be really, really, really narrow, okay? But the reason why I put the absolute value is because you have to take into account the negatives as well, Okay, hopefully that made sense. All right, so what does the A control? What does the A control here? The A controls basically the slope of the graph and the direction. So that's what A controls. So when you multiply a number on the outside, it's going to affect the graph and the direction, whether it's going to be narrow, wider, or whether it's going to be facing up or facing down. Okay? What does the K control? The K, this affects the vertical shift of the graph. Basically, if this was like a video game, the K would move your function up or down. So if you wanted to move your function up 10 units, well, guess what? What do you need to do? Plus 10. Okay. What does H affect? H affects the horizontal shift of the graph. Okay, so this value right here, so we're going to go over examples. This one's a little tricky. So for example, if you saw that this was x minus 2, so we'll just write a little, we're going to put x minus 2. Did it shift left or right? Let me just reset this back. Now remember, it's x minus the h value. So your h value is what? Is it -2 or +2? This is the tricky part. X minus the h value. The h value is a +2. So just focus on this. That's all you're focused on there. Well, -2, minus a +2. So that means in this situation, it was translated to the right 2 units. Let's check it. Let's take my h value, 1 and 2. You see that? Yeah, because I'll be honest, when I first learned this, when I saw -2, I automatically wanted to say, oh, it goes left 2. It took me a while to really understand what this meant and why it goes to the right 2 instead, because it's minus your h value. H is the one, so if you, H controls left or right. Now, if you saw x plus 2, some of you were like, hey, Mr. B or Mr. Godaboo, you're adding 2. So it's shifting to the right 2. No, not quite. You have to think, okay, how did I get there from x minus h? How did I get from here when I was subtracting something to now adding 2? Because there's always subtraction here. Well, guess what? How did you get there? You did it x minus -2. So really, x plus 2 is x minus -2. So really, this is a shift to the left. -2. So that's the tricky one, okay? So this is left 2 units. Okay, so that was a lot. Honestly, what I would really want you to do, just pause, reflect, give yourself a break. Just give yourself a break, because that was a lot, and you're going to be using this, okay? So take a break, take a walk, do some push-ups, do a workout, I don't know. All right, and then come back. All right, so here we go. So we're going to use what we know now to describe what happened to our original function. So right now we have that red line right there. That's the original, our parent function, the absolute value of x. And we need to figure out, okay, so we're doing these things, these operations here. What happened? What is going on? How do we expect our new function to look like. And what I want you to do is draw a rough sketch. So what I want you to do is explain any transformations. Does it get, what I mean by that, does it get wider? Does it get narrow? Does it shift to the right? Does it shift to the left? Does it move up or down? Okay, so, and then I want you to draw a rough sketch of it. Okay, so I really want you to think about this. So take a second. This is going to help a lot. Okay, so for A, here we go. For A, so here's 4. See that? Now remember, we're multiplying that. That's the A value. So what happens when A increase? It becomes narrow, narrow, and then it's -3. Now it's not inside the absolute value symbols, it's outside, so that's your K value. So it shifts down to, 3 units. So what does that look like? So I'm drawing a graph that is narrow and shifted down 3 units. So it would look something like, oops, if I can draw, that would be great. 1, 2, 3. So it would look something like that. Notice how your original function got narrow and then got shifted down 3 units. Okay? So what I'm going to do on this is help you complete the table, okay? So here we go. So x is -2. And then I'm going to plug in -2 into my function. So I'll show you how that looks like. So y equals 4 times the absolute value of -2 minus 3. So from there, what's the absolute value of -2? +2. So it's 4 times 2 now. So notice how my parentheses went, sorry, my absolute value symbol went from the sticks to parentheses, because that means I've taken the absolute value of it. Take away 3. So 4 times 2 is 8. Take away 3, which is 5. Okay, so that's kind of how you would approach that. That is 5. So I'm going to type that in here. Hopefully, you'll see the point pop up. Ooh, I messed up here. Huh. What did I do wrong? What did I do wrong? 4 times 2. Looks like I did everything right. -2 comma 5. Oh, yeah. No, sorry. I thought sorry. I was a little confused. This red graph is the absolute value of x, the original. So we don't expect these points to land on the red line because that's the original. We're trying to find the new one. Next, -1. We're going to plug that in. 4 equals 5. 4 times the absolute value of -1 minus 3. Take the absolute of -1, which is +1. So 4 times 1, take away 3, is just 1. So my y value is 1. Now, next, 0. Y equals 4, absolute value of 0. Take away 3. 4 times 0, take away 3 is -3. So I'm just going to continue on. You're going to notice with absolute value functions, you'll notice a pattern. Let me do the next one. 4 times the absolute value of 1, take away 3. Absolute value of 1 is 4 times 1. Or sorry, the absolute value of 1 is 1. 4 times 1, take away 3 is 1. So what I meant by that is, with absolute value functions, once you notice that another value starts to repeat, it's symmetrical. So that means this value here is going to be 5. But I like to prove it. Well, no, it's going to take, you'll see it. You can do it on your own. But now we're going to connect these dots and look at our new function right here. It's a function that got translated down 3 units, and it got narrow. Okay, so that's what I want you to do on this next one. This is what you're going to do. I'm just going to kind of give you the heads up of what it should look like. So here's our function. Now think about it, 1/4. That a value is 1/4. Let's think about it. When my a value is 1/4, so it decreases from 1, decreasing from 1, what happens to it? Do I expect it to be wider or narrow? Hopefully you said narrow. And then that x minus 1, that h value, okay, where's my h value? So the h value, the shift here, it's x minus 1. So what do I expect? Is it going to shift to the right or is it going to shift to the left? This is the tricky one, remember? A lot of you are going to want to say, oh, it's minus 1. It's going to go to the left. No, no, no. It's minus a positive. So it's a positive 1. So it's actually shifting to the right 1. Okay, so you're going to draw a rough sketch. You're going to calculate it, and you're going to see that this is going to be much wider and shifted to the right. And don't get confused like me. This graph right here is the original, the absolute value of x. That's your function, absolute value function. And if your dots are not appearing on the red line, that's okay, because it shouldn't. Because you're drawing, it should be calculating your new graph, okay? All right, moving on. 21, come on, here we go. All right, so same idea here. Think about it. So I have 3 things. I have an a value, something on the outside of the absolute value. I have something inside of my absolute value symbol, and I'm adding something on the outside. So I have an a, basically, I have an h, and a k. So 3 things are happening. So describe the transformations. First, start with the negative. Okay. First, start with the negative. So if you have a negative a value, what do you expect it to do? Open down. Now, that h value is plus 3. Don't get confused. You're going to think, oh, plus 3, shift to the right 3. No. How did you get to plus 3? By doing minus a negative 3. So really, it's negative 3. So you actually shifted to the left. Left 3 units. And then what does the k do? Move it up or down? So it's plus 5. Up 5 units. So I'm going to draw a rough sketch. So I know it's going to open down. It moves to the left 1, 2, 3, and then goes up 5. So basically what I'm looking at is 1, 2, 3, left 3, up 5, and then draw my V facing down, just like that. So that's what I expect, okay? So on this next slide, I want to go, I'm just going to calculate 2 of them, but I expect you to calculate all of them, because some of you might get confused on how to deal with the negative on the outside. So y equals negative absolute value of x plus 3 plus 5, and then my y value. So the first one I'm going to plug in is negative 2. So y equals negative 2 plus 3, close it. So negative 2 plus 3 is 1. What's the absolute value of 1? 1. But you got to multiply this by the negative on the outside. So you actually have the absolute value of 1, which is 1, then multiplied by the negative, which is negative 1 plus 5. So negative 1 plus 5 is 4. Now remember, don't get confused like me. I should not expect to see this dot on the red line. Next one, negative 1. Y equals negative 1 plus 3 plus 5. Okay, negative 1 plus 3, 2. Absolute value of 2 is 2 times the negative 2 plus 5, which is 3. Okay, I'm going to type that in. 0. And you would just continue on. I think what would help is if we did a value for -3 here, because you would be able to, you would clearly see what's happening here. Let's do a value of negative. I know it doesn't say on our table, but I want to do -3. So y equals negative absolute value of -3 plus 3 plus 5. So what I'm doing is I really want to create the v, because if I continue on, I'm only going to create one side of the v shape. That's why I'm adding on -3, because I want to see the other side of it coming down. Okay, that's what I'm doing right now. So -3 plus 3 is 0, and then 0 times a negative is just 0, plus 5 is 5. So there's a 5. Sorry, I can't type that in. So I have to actually graph this, -3 comma 5. So 1, 2, 3, 5. Okay, and I want to do -4. I know it's not on the table, but I just want to show you that you do get the V shape, okay? So -4 plus 3 is -1. The absolute value of -1 is 1, but then you're going to multiply that one by the negative, which is -1, and then -1 plus 5 is 4. So that I'm going to plot -4 comma 4, which is right here. So then I would just connect the dots, and hopefully that looked something very similar to what I drew in the one before. Okay, so I know this is pretty. It's a lot, but it's going to pick up, and you're going to get better at it. Okay, so I want to compare. How does the absolute value function differ? How does the absolute value graph y equals absolute value of x minus 6 differ from the original? Now, here's the thing. You got to ask yourself, whenever you see these type of questions, you got to ask yourself, did I change the a value? Did I change the h value? Did I change the k value? Okay, and this is going to help. So I'm doing a -6. Okay, I did a -6. All right, so I'm changing the h value. So let's go down here. Now remember, I'm gonna stress this every time. A lot of you are gonna be like, oh, Mr. B, Mr. Godaboo, it's -6. So you shift to the left 6. Not quite, because it's minus h. It's minus a positive. So in this situation, it's -6. 6 is a positive number. So you're actually shifting it to the right 6 units. So I'll take my chances. Oops, what happened here? What happened? Well, you know what? I'm just gonna make this bigger. Technical difficulties. This is what happens. Remote learning. Let me just get back here. Let me unzoom or zoom out. All right, perfect. So it's shifting to the right 6 units, okay? Because it's minus a positive 6. All right, moving on. All right, how does the absolute value graph of y equals 8 times the absolute value of x differ from the original absolute value of x? So you got to ask yourself, what are you changing? Are you changing the a value? Are you changing the h value? Are you changing the k value? So if you notice, I'm changing the number on the outside here, which is a. And what does a do? It affects how the slope of it. It makes it narrow, wider, or facing down. So in this situation, it's 8. So the value of a increased, so it's going to make it narrow. The graph is narrower. I can't pronounce that. Moving on. Ooh, we got a lot of things going on in this one. All right, so I mean, you got to just go back to your graphic organizer. You have to identify, all right, what am I changing? I noticed that there's an a value of 1/5. How does a value of a that is 1/5 affect your graph? Well, 1/5 is in between 0 and 1, so that means your graph is wider. Okay. Next, oh, I'm adding 7. But this is on the outside of your absolute value function. So that's the k value. So let's see, the k value, when the k is positive, translates up 6 units. Shifted up. See how that works? So you got to pay attention to whether it's A, H, or K that is being changed, okay? So next one. Okay, so I can see that the A value, there's no A, well, technically there's an A value. A value is 1, but there we don't have to worry about that, okay? But I do have an H value. It's a positive one. So I'm going to stress it again. A lot of you are going to be like, oh, it's a positive one, so it's going to shift to the right. Not quite. How did I get to positive 1? I had an H value of -1. That's how I got it. So because it's X minus H. H controls whether you move right or left. And then, so it's X minus -1. So this -1 moves it to the left 1. But we know that X minus -1 is X plus 1. So that's why X plus 1 is actually a shift to the left 1 unit. Okay, you see that? That one's a tricky one. And like I stated before, it took me a while to really straighten that out. I always thought do the opposite, but I don't know if that works for you. But that's why I'm trying to really clearly show you how positive 1 for the H is really a shift to the left. And then here, my K value is -3. That was straightforward. That's like, oh, -3 moves down 3 units. So shifted down 3 units. Moving on. We're almost there. Thank you for bearing with me. I know this one was a little longer than expected, okay? All right, directions. Write an equation of the absolute value graph when the given with the given description. So the equation of a graph is shifted 8 units up from the original, and it opens down. So what would the equation look like? What kind of equation would you type here? Y equals. Now, the absolute value symbol, what you're going to have to do is press Shift, and where you see the Enter button on your keyboard, right above it, there's that little backward slash, but there's that vertical line there on your keyboard. If you press Shift and right above Enter, you'll see that. You'll type in the vertical line. So the key is right above where it says Enter on your keyboard, okay? And you're going to have to press Shift to activate that vertical line. All right, so notice that my blue red line got covered by a blue line. So the blue is what you create. So right now I created a replica of the red, the original. But I want the graph, I want this blue line to be shifted 8 units up. So, I mean, this gives you instant feedback. You could do +8 here. Notice it actually moved to the left. So where do we have to put +8? On the outside, right? Because the value, the K, affects the vertical shift going up or down. Now, I need it to face downward though. So what value, A, H, or K affects facing up versus facing down? The A value, and it would have to be negative. And there you go. So we have an equation that was shifted 8 units up. See how it's up 8 units? You can't see me pointing. Silly me. See how here it's 8 units. It moved up 8 units. And now it's facing down. Okay? 28. All right. So there's my original. The red line is the absolute value of X. That's my original function. And what I want you to do is shift it 5 units left and then 12 units down. So let's type in the original first, okay? Y equals the absolute value of X. All right, notice how the blue replaced the red graph, okay? So the equation was shifted 5 units to the left. So I want it to go left 5 units. So remember, it's always minus h. Okay, so the h value controls left or right. If I wanted to move to the left, 5, I'm going to type in -5. Now remember, you wouldn't put x minus -5. You would write x plus 5. So you see that? X plus 5. So I just moved my blue graph from where it was originally, where the red graph, you see that there? I moved it to the left, 5, and then I need to move it down 12 units. So I'm going to change the value of k, minus 12. There you go. That's all I did. All right, last one. Thank you for being, hopefully you took some breaks. This one was a little longer than expected, okay? So the equation of a graph is shifted to the right 10 units. All right. Ooh, but shifted to the right 10 units from y equals x plus 1. All right, this one's a little tricky. So let's type in the original absolute value of x plus 1. So this was a little tricky. So usually we would use the absolute value of x, but this one's this is like the challenge problem. All right, the equation of the graph, so this graph is shifted to the right 10 units. So basically you want to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 right there. So we want our graph, our little vertex right there to start. So if I want to move it to the right 10 units, so gotta think about it, minus -1, right? Because x plus 1 is the same thing as x minus -1. So if I want to move it to the right 10, so -1 plus 10 is 9. And there you go. You essentially just moved it to the right 10 units. I know, that one was a little tricky. Okay, so hopefully you attend the optional Google Meets, and hopefully you just stay safe and healthy. All right, take care.